Hello, I am Nayan Sethi and I am going to talk about free space optics. So, what is free space optics? Free space optics or FSO is an optical communication technology using light propagating in free space to transmit data between two different points. It is used in conditions where fiber optic cable connections cannot be used because of their high cost. Free space optics is a fiberless, laser-driven technology supporting high bandwidth along with easy-to-install connections. The light pulses are transmitted through the atmosphere in small, conical-shaped beams using low-powered lasers. The most important advantage of using FSO is high bit rates, low bit error rates, license-free long-range operations, and immunity to electromagnetic interferences. So, let's talk about why should we use FSO or free space optics. For that, we'll first talk about the last mile problem. So, what is the last mile problem? It basically refers to the gap between a broadband service provider's infrastructure and a customer's home or workplace. The wide area connections between major cities are extremely fast and fiber-based, which give speed up to 2.5 gigabits per second. But the local area networks are around 100 Mbps per second. The connections between these two networks is a lot slower, which is around 0.3 to 1.5 Mbps, which causes the bottleneck of the speed. Only about 5% of the commercial buildings are lit with fiber. So, since fiber offers speeds up to 2.5 gigabits per second, why don't we just use more fiber cables? Because it costs a lot of money. There are permits, we have to do trenching, and it costs a lot of time. But with FSO, we can just use it through the windows. We don't need any permits and no digging and no fees. So, FSO is much better than using fiber optic cables. So let's first understand how does a fiber optic cable works. As you can see, the fiber optic cables are connected through glass fiber strands. It consists of a light source and a detector, and the pulses are passed from the light source to the detector. It can carry speeds up to 40 gigabits per second, which is like really fast. So now let's see how does the FSO works. Firstly, the network traffic is converted into pulses of invisible light representing ones and zeros. The transmitter then projects the carefully aimed light pulses into the air. A receiver at the other end of the link collects the light using lenses or mirrors. The received signal is converted back into fiber sensors. Now, the reverse direction data is transported the same way. It's a full duplex connection. Anything that can be done in fiber can also be done with FSO. So, why should we use free space optics? The beams are only a few meters in diameter at a kilometer. It allows very close spacing of links without any interference. There are no side lobes. It is highly secure. It is an efficient use of energy, and the ranges of 20 meters to more than 8 kilometers are possible. So basically, to list down the advantages of free space optics, there are no interferences. It is unlicensed. It is easy to install. It can be used through the windows or from the rooftop. No digging or no trenching and no permits needed for the installation. The fiber like there are the data rates are like fiber and many deployment options, and the equipment is very fungible. There are a lot of challenges involved with FSO. So, to list some of them, there could be fog between the buildings, which can cause obstruction for the beam of light. There could be window attenuation, there could be scintillation, or the motion of the building due to thermal expansion. So, now let's talk about fog. The absorption or scattering of optical signals due to airborne particles. Primarily, fog can be rain, snow, smoke, or dust. It can result in a complete outage FSO wavelengths and fog droplets are close to equal in size. So a typical FSO system works 2 to 3x farther than the human eye can see. High availability deployment requires short links that can operate in the fog. So, other challenges which are low clouds, rain, snow, and dust. Low clouds is very similar to fog and may accompany rain and snow. Rain. The drop sizes are larger than fog and wavelengths of light. Extremely heavy rain, can't see through it, can take a link down. The water sheeting on windows can prevent the beam from traveling optically. If heavy snow, it may cause ice to build up on the windows and it may cause a whiteout conditions. In sandstorms, likely only in desert areas, rare in the urban core. So now let's talk about scintillation. What is scintillation? The beam spreading and wandering due to propagation through air pockets of varying temperature, density, and index of refraction. Almost mutually exclusive with fog attenuation, it results in an increased error rate but not complete outage. The next challenge is window attenuation. So, uncoated glass attenuates around 4% per surface due to reflection. A tinted or insulated window will have a much greater attenuation. The possible trait high altitude rooftop weather losses versus window attenuation, you can see it in the graph. So the next challenge we are going to talk about is the motion of the building. It could be of three types due to the tilt, the sway, or the vibration of the building. The tilt could be due to the thermal expansion of the building due to heat, sway could be due to wind, and vibration could be due to heavy equipment, slamming of the doors, etc. etc. So, all these things could cause to mess up the alignment of the transmitter and receiver, which could stop the signal and be on hold. Now to conclude, FSO offers many advantages over existing techniques which can either be optical or radio or microwave. Less cost and time to maintain the setup are the main attraction of FSO system. Optical equipment can be used in FSO system with some modifications. The merits of FSO communication system and its application area make it a hot technology, but there are some problems arising due to attenuation caused by the medium. FSO system possesses some problems like attenuation in medium that can affect the performance of transmission as power loss would be there. But extra care and pre-study of the medium can guide what type of parameters to be considered before setting up a system. Many studies are going in this perspective to minimize the effect of attenuation by introducing new system designs like WDM-based FSO systems. Different models based on these studies are used before installing it at the location. This can lead to improvement of the system. Different techniques like OFDM, WDM are the new approaches which will improve the system performance with high speed and longer distance. So new techniques can be designed by combination of these, and enhancing these techniques, system designing can be improved and the demerits of FSO system would be reduced to a minimum level. So this is the end of the video. Thank you for watching it and hope you all liked it.